Hello, I'm here to go over the last portion of Chapter 3 on cells. We covered the first part of the chapter, which covered the organelles and their functions, as well as diffusion and osmosis, and the environments that cells can find themselves in, be them hypertonic, hypotonic, and isotonic. One other additional piece of information that we need to cover is found on page 76, as it identifies the different mechanisms by which a cell will either take in fluids or solids and how it will release fluids or solids. So we have two terms, endocytosis and exocytosis. Let's start with exocytosis. Exocytosis is all-encompassing. The prefix exo means out. So exocytosis is the mechanism by which a cell will get rid of either a fluid or a solid. There's no differentiation. Exocytosis is getting rid of all of it. However, endocytosis, the prefix endo meaning inside, comes into two categories because it actually does differentiate whether or not a fluid is being brought in or a solid is being brought into the cell. Penocytosis is the mechanism by which a cell will bring in a fluid or liquid, while phagocytosis is the mechanism by which a cell will bring in solid matter. So they both fall under the umbrella of being endocytosis because the cell is taking in either a fluid or a liquid. But if we want to be much more specific, then we would identify penocytosis as it taking in a fluid, while phagocytosis is the cell taking in a solid. Okay, so that information, like I said, is found on page 76, which will then move us right into page 77 in the cell cycle. So at this time, if you don't already have it, you need to make sure that you have this diagram available. I have plenty of, I actually have this diagram available for you on Blackboard. So if you need to print it off, please make sure you do so before you go through this segment of the video lecture, because we will actually be filling in information on the diagram. Once I complete filling in the information on this diagram, it will be posted on Blackboard for you to access. So you will have a blank copy such as this, and then I will also make sure that I post the information as we write the information on this document. Okay. First things first, we need to identify the stages of the cell cycle. There are 5 stages of the cell cycle. Of these 5 stages, there are 4 stages of mitosis. Let me show you what I mean. These are the stages of the cell cycle: interphase, prophase, metaphase, anaphase, and telophase. So I'm just going to write the letters right there, right now. Okay. Of course, the I stands for interphase. This will be prophase, metaphase, anaphase, and telophase. Those are the 5 stages of the cell cycle. However, within the cell cycle, we have 4 stages of mitosis. Mitosis is the cellular division of normal bodied cells. Sometimes they're called somatic cells, or all of the cells in our body that we have, with the exception of the gametes. The gametes are our sex cells, and that division we'll talk about when we actually get to the reproductive system. But all the other cells that we have in our body, such as skin cells, muscle cells, bone cells, they undergo 5 stages in the cell cycle. But these 4 stages right here are the stages in which the cell is actually undergoing cellular division. Okay. So looking in the textbook, you'll notice that the first stage of the cell cycle, which is accurate, is interphase. So looking at our diagram, I've segmented it off because I'm not concerned that you know the early and the late stages of some of the stages of mitosis. I just want you to know that prophase, metaphase, anaphase, and telophase are the stages of mitosis, while interphase, prophase, metaphase, anaphase, and telophase are the stages of the cell cycle. Okay, so if you're trying to figure out an easy way to remember those stages, if you're trying to remember the stages of mitosis, you could very easily make a mnemonic. A mnemonic is when you take the first letter of each word and you create your own sentence to help you remember. Now, since all of these end in phase, you just have to remember the beginning of the word. So, for the stages of mitosis, we have prophase, metaphase, anaphase, and telophase. So it's kind of PMAT. And we create a sentence from that. The sentence that you could create that I think might be helpful in this class would be, pass my anatomy test. So by creating that sentence, you have the first letter of each word, which would help you to remember prophase, metaphase, anaphase, and telophase. However, if you were trying to remember the stages of the cell cycle, since there are 5, you could then say, I passed my anatomy test. Then therefore you would have interphase, prophase, metaphase, anaphase, and telophase. So that's how you remember the differences between the stages of the cell cycle and those of mitosis, which is inclusive in the cell cycle. Okay, I'm missing what I wiped my tape with. Okay, no problem. All right, so we're starting with interphase. Interphase typically is a stage where we initially believe that not too much was happening. And if you are looking at your diagram, you'll notice I've drawn in a cell right here. This cell, we really don't see a whole lot other than the nucleus. This stage is interphase. So at the top of that diagram, please indicate that that's interphase. I know it's backwards, I'm sorry. Okay, so what's going on during that particular stage? Initially, it was thought that not too much was happening, but actually within interphase, there are certain things that are going on. Number one, the genetic information of the cell is being recopied in preparation for mitosis. So all of the DNA and RNA, that genetic information is being copied in order to pass on to future generations of cells, so to speak. You'll notice by looking at the diagram, you can't really see any types of chromosomes, and chromosomes are actually those structures that have our genes, and the genes can carry the genetic information that makes the cell uniquely its own. It makes what's you and what's me. So as humans, we have 23 pair of chromosomes, and on those chromosomes we have our genes. So you really can't see any differentiation here. All you can pretty much see is that the nucleus is present and everything else about the cell looks normal. We see the cytoplasm. We can't really see any of the organelles inside of the cell, but that's pretty much what goes on in interphase. Now, the next block of cells that you see, you will notice I have 1 and 2 together. This entire block is representative of prophase. This is when the cell is actually beginning to undergo cellular division. Prophase. Now, even though I may not write it up here, when I actually post it on Blackboard for you, I will have the information that I'm discussing as far as what goes on in that stage. All right, so there are a couple of things that I want you to see here. I'm trying to see, actually. No, I don't have it present. Okay. There are a few things that go on here. Number one, there are a couple of things I want you to see that are different here. Notice that inside of the nucleus, remember we have that nuclear envelope that surrounds the nucleolus and the nucleus? It actually protects and discerns what can come in and go out of the cell. Well, inside of the nucleus, you will notice those chromosomes that are not visible here are now visible here. They become long and thin. And in addition to that, at the beginning of the stage, you will notice that the membrane, the nuclear envelope or membrane, is still intact. But by the time we get over here, you no longer see that line that keeps the membrane, the nuclear membrane bound. Okay, so we see that the chromosomes are long and thin. And then we also see the development of something over here. These lines, and I'll make them a little darker, are what are referred to as centrioles. The centrioles are going to be very important in another step or another stage of mitosis because they are actually going to help to pull those chromosomes apart once they move to the opposite poles of the cell. So, first, we see that the chromosomes become long and thin in prophase. We also see that the centrioles appear during this stage. And then by the end of this stage, the nuclear envelope or nuclear membrane has disappeared, and we see the development of these long, thin fibers. These long, thin fibers that I've made just a little bit more visible are called spindle fibers. These spindle fibers will eventually attach to the chromosomes to help to pull them apart. In addition to that, you'll see very small fibers that almost look like sunbursts on the outside of the centrioles. These are called aster rays, A-S-T-E-R rays. And you'll notice that they are on the outside of the centrioles that are located here. In addition to the chromosomes becoming long and thin, now they have actually paired up. All of this goes on during prophase. Once prophase has finished, then we move to the next stage. So where you see I have bracketed number 3 and number 4, we move to the next stage of mitosis, which is called metaphase, M-E-T-A phase. One of the key things about metaphase, it starts with M. And you will notice in this diagram right here, the chromosomes line up in the middle of the cell. Middle starts with M. That should clue you in to metaphase having the chromosomes to move to the middle of the cell. A couple other things happen. You'll see that the spindle fibers are now attached to the chromosomes, and the centrioles have now migrated to the opposite poles of the cell. But the important thing is to remember, metaphase starts with M, chromosomes line up in the middle, and centrioles migrate to the opposite poles of the cell. Once we reach the end of metaphase, we move to the next stage of mitosis, which is anaphase. Anaphase starts with A. During this stage of mitosis, the chromosomes are then pulled apart. Notice? They are pulled apart during anaphase, and they begin to migrate to the opposite poles of the cell. The centrioles are still intact, the aster rays are still formed on the outside. These spindle fibers that are attached to the chromosomes will contract to pull these chromosomes, half of the chromosome, to the other parts of the cell. And you will notice that the cell itself actually goes from a rounded-like structure to becoming more ovoid in shape. Once we get to the end of this stage of mitosis, anaphase, they are pulled apart. we will move into the last stage of mitosis, which is called telophase. So diagrams number 7 and 8 are representative of telophase. Telophase starts with T. Oh, I don't want you to think that's interphase. Let me do something else. Telophase starts with T. Thus, we have the development of 2 daughter cells. Telophase T, so the development of 2 cells occurs. And the interesting thing about these 2 cells is that they are identical to the parent cell in every way. They have the same number of chromosomes. Everything about the original parent cell that we started off with here, the end product is the same as what we had here. But before we get to this point, the development of the 2 daughter cells, we actually have some other things that are going to occur during telophase. You will notice that it seems as though that elongated cell that we saw in anaphase begins to kind of cleave inward. This area where it begins to kind of pinch in is referred to as the cleavage furrow. These areas here where it literally begins to pinch in, and you can notice that there's a development of a layer right here that's actually going to separate both of the cells. In addition to that, the chromosomes once again are becoming long and thin, but in order for there to be a development of 2 cells, everything has to split. The nucleus has to split, the cytoplasm has to split, and that occurs during telophase. Division of the cytoplasm is called cytokinesis. If you're trying to find this information in your text, you will notice that when you look at number 4, which is telophase, on page 80, it's discussing the stage of telophase. But just beneath that, it says cytoplasmic division. Cytoplasmic division is cytokinesis. When the cytoplasm divides, the nucleus itself also has to divide, and that occurs during telophase as well. The division of the nucleus is called karyokinesis, K-A-R-Y-O-K-I-N-E-S-I-S. So we've got 2 things that occur that are divisions. Division of the cytoplasm, cytokinesis, division of the nucleus, karyokinesis. In addition to that, during telophase, there are some other things that will begin to happen toward the latter stage, toward the latter part of that phase. Because the chromosomes have now become long and thin, eventually they will no longer be able to be visible. Once they are no longer visible, we then have the redevelopment of that nuclear membrane to hold that genetic information inside of the nucleus. Then from that point, you'll notice in this diagram up here, initially you'll see the centrioles. They're located here, and you can see them here. But over a period of time, the centrioles will also disappear, and then the cell will go back into the stage of interphase, where it's preparing for the next time that it's going to divide. Now, cellular division can occur very quickly in some cells, and in other cells it might take a longer time. I'll give you a perfect example. If you've ever had a hangnail that you may have pulled, or it got caught on something and it ended up being pulled, hangnails typically regenerate very quickly if you leave them alone, and as long as they're not very deep. Even if they are a little deeper than just a superficial hangnail, they will regenerate very quickly because their mitotic dividing time is shortened. well, it's not shortened, but it just doesn't take that long for epithelial tissue. Epithelial tissue are the types of cells that is the type of tissue in which we will find skin cells. It doesn't take them that long to regenerate. However, if you have ever torn a muscle cells take a lot longer to heal than those that are a part of the epithelial tissue, or like a simple squamous type of cell, which is what our skin is made of. So therefore, the mitotic division is longer in a muscle cell than it is of one of the types of skin cells, such as simple squamous epithelial. So I say that to say that the cellular division time of different types of cells may either be a shorter period or it can take a longer period of time. Skin cells, a shorter period of time for those cells to undergo their mitotic division, while muscle cells take a longer time to undergo their mitotic division. That was the last of the information for Chapter 3. If you have any questions, please feel free to contact me. Have a wonderful day.